Hi, welcome to my video on rational functions, and this video will be on the greatest common factor. Graph each f of x equals x plus 1 divided by x plus 1. And notice that these two binomials are the same, so what we have is y equals x plus 1 over x plus 1. Notice that they cancel out to give me a 1. So that means that when they cancel out, I have y equals 1. So that's a horizontal line, y equals 1. But we have to remember that we cancel out x plus 1. So if you have, I'm going to say, we're going to have a hole when x is negative 1. So the hole occurs when x plus 1 equals 0. So x is equal to negative 1. So the hole is that when x is negative 1. But it's not a vertical asymptote because it canceled out, it was removed, it didn't stay. So vertical asymptote is only when x plus 1 stays in the denominator and is not removed. But in this case it's removed, so the hole is at x is negative 1 and y is 1. So the hole is that x is negative 1, y is 1. The hole is right here. So what we have a horizontal line of y equals 1. There it is right there. There's the horizontal line, y equals 1. But that horizontal line has a hole at this point of negative 1, 1. Now we have another one, similar. F of x equals 3x plus 6 over x plus 2. So that's y equals 3x plus 6 over x plus 2. And that's factorable. 3 is the common factor in this binomial. So take the 3 out, we get x plus 2 over x plus 2. And again, the x plus 2's cancel out. So we get y is equal to 3. And that means we have a horizontal line where y is 3, but because the x plus 2 cancels out, so we have a hole at x plus 2 equals 0. So we have a hole at the x coordinate of the point, which is negative 2. So that's at x is negative 2, y is 3. So negative 2, x is negative 2, y is 3 is right here. So there's a hole right here on this horizontal line, which is y equals 3. And you can plug this into a graphing calculator and you'll see this hole. There's the hole at this point. Negative, so this point here is negative 2, 3. And this point here is negative 1, 1. So let's continue with some more examples. Again, notice the GCF, there's a GCF in the numerator and denominator. Now we have this one, f of x is x squared minus 1 over x minus 1. So we get y equals x squared minus 1 over x minus 1. X squared minus 1 is the difference of two squares, is x plus 1 times x minus 1. Difference of two squares divided by x minus 1. So the x minus 1 again cancels out, so I get y equals x plus 1. And so again, because the x minus 1 cancels out, we have a hole when x minus 1 equals 0. So we have a hole at when x is 1. So when x is 1, we have an equation. So it's at y equals x on this line. This is a line which has a y-intercept of 1, a slope of 1. So when x is 1, we put 1 in. We have a 2. So the hole is at when x is 1, y is 2. So we have a line. So the y-intercept is 1, which is right here. The slope is 1 over 1, which is, this is 1, so it's 1 over 1. So we rise 1, run 1. We rise 1, run 1. So we have a hole at 1, 2. X is 1, Y is 2. So we have a hole right here. There's a hole in this line, and this line, there it is. So remember, this is a line with a y-intercept of 1 going up 1, right 1. So this line is y equals x plus 1, but it has a hole at this point, 1, 2. Now, I have this on my calculator, so I'll show it to you now. Here it is. I have a graphing calculator, and so on this graphing calculator, I'll turn it on, and I'll show you the equation. So this equation is the same as this one. It's x squared minus 1 divided by x minus 1. So I'm going to graph that over, and I'll show you the interval. The x is minimum at -1, maximum at 5. The y is minimum at -1, maximum at 5. There's the interval. So I'm going to graph that line. So there's the line. Excuse me, I just move it. There's the line right there. There's the 1, up 1, right 1. There's the line, but you can't see the hole in it. So what I'm going to do to show you the hole, I'm going to change the coordinates out the window. So I'm going to have x going to 0, up to 2, and the y is going to go from 1 to 3. And the reason I changed that, so you can see the hole that's in this line. You couldn't see it just then. Now watch when I press graph. So, right there. There it is. I'll bring it down, see if you can see it. The hole is right there. You can see that. And I'll show it to you again. There's the hole right there. That's the point 1, 2. The hole that's in this line. So this is the line going through here. There it is. It's the same as it right here. And that hole there at 1, 2. There it is right there. And I had to zero in on it. Change the again, I changed the window from x going from 0 to 2 and y going from 1 to 3 to zero in on that. So that's shows you that there is a hole. I didn't do that for all of them. I just did it for this one. Now let's look at number 4. Again, we have y, and we have x squared plus 5x plus 6 all over x plus 3. And x squared plus 5x plus 6 is factorable. X squared is x and x. The factors of 6 to give you 5. Because the product is positive, sum is positive, so it's 2 positive. So what's the factors of 6 to give you a 5? It has to be a 3 and a 2. So that's the factorization of this trinomial divided by x plus 3. And again, the x plus 3 cancels out. So I have y equals x plus 2. So I have a line that has a y-intercept of 2, which is here. The slope again is 1 over 1. So there's the y-intercept of 2. And we go up 1, right 1, and up 1, right 1. But we have a hole because the x plus 3 is removed. So before I draw this line, let's find out where that hole is. So the hole is that when x plus 3 is removed. So we make x plus 3 equals 0. So that means that x is -3. And so it's going to be at, let's take the line, y equals x plus 2, and sub in -3 plus 2, that's -1. So the hole is at x is -3, and let's see, I got an x plus 3 here, and x plus 2, so that's at negative 3, negative 1. So again, we make x plus 3 equal to 0. We get x is negative 3. Put x is negative 3 into here, and we have x plus 2. So put negative 3 in, you get negative 1. So when x is negative 3, y is negative 1. So when x is negative 3, y is negative 1. That's right there. So the hole is right here. So that line, as you come down 1, left 1, down 1, left 1, down 1, left 1. So there's the hole. So the line is, oops, not broken. It's a line. So there's the line. There it is there. With this point is the hole in it. And so that line is y equals x plus 2. Okay, let's continue with some more examples. And again, this is what, when you go to calculus, this is what they call the removable. It's removing discontinuity, but that'll come up later on in the units. Now we have another one. We have y equals, and notice we have a polynomial, which is a quadratic divided by a linear, but we have to factor this to find out. We can factor. So if we factor, let's go over here and factor negative 2x squared plus 3x plus 2. So let's take the negative out first. So we take the negative out, we get 2x squared minus 3x minus 2 equals 0. And so we have, notice that in this trinomial, the product is negative 2 times, it's because that a is not 1, so the product is 2 times negative 2, which is negative 4. The sum is in the middle as a negative 3. So what are the factors of 4? It's 1 times 4 or 2 times 2. So which pair of factors will give me a 3? These won't, so it's got to be 1 and 4. But the product is negative, the sum is negative, so it has to be negative 4 times 1. So that means we put in negative 4 with an x, we put a 1 with an x. So I changed negative 3x to negative 4x plus 1x. And we factor that. In this, we're going to do grouping. So we're going to take the 2x out of the first two terms. So that's an x minus 2. We're going to take a positive 1 of the next two. That's an x minus 2. And as you can see, that x minus 2 is common. And 2x plus 1 is what's left as we group them. So that becomes the negative outside of x minus 2 and 2x plus 1 all over x minus 2. So notice that the x minus 2 is removed, so we have a negative outside of 2x plus 1, which means we have a negative 2x minus 1. And as in all of these that I'm illustrating, there's a hole. So where's the hole? Is that x minus 2 is equal to 0. So because we scratch this out, we have to look at the value of x, which will make this a 0. And that value of x is when x is 2. So if x is 2, so y equals negative 2x minus 1. So we put, again, a 2 in here. And that gives us negative 4 minus 1. That gives us a negative 5. So there's a hole when x is 2, y is negative 5. So when x is 2, which is right here, y is negative 5. So let's go right here. There's a hole right here at this point. But the line is got a y-intercept of negative 1. And we go negative 2 over 1. So we go down to right 1, down to right 1. So there's the hole right there. So let's draw this, and I'll draw this. There it is. And again. So this equation here is y equals negative 2x plus 1. Sorry, negative 2x minus 1. That's the equation of this line, which is a linear, and there's the whole at 2, negative 5. Okay, and we have one more, just a little tiny bit different. So we have f of x, that's the y, equals x plus 1 over x squared minus 2x minus 3. So that's x plus 1, and this is factorable. And let's see what the factor, x squared is x and x. Factors of 3 are 3 and 1. And the product is negative 3, the sum is negative 2. So it has to be negative 3 plus 2. Because the product is negative, it has to be a negative and a positive or a positive and negative. But the larger factor is negative because of the 2. And we have the x plus 1's cancel out. So we get y is equal to 1 over x minus 3. So, again, a little bit different than the other ones because the other ones were all linears. So this time we have a vertical asymptote because we have 1 over x minus 3. We have a vertical asymptote at x minus 3 equals 0. So we have a vertical asymptote at x equals 3. So there's the vertical asymptote at x equals 3. Notice the x minus 3 is not removed from the denominator, so the vertical asymptote at x equals 3. Now, what we have is, let's look at to see if we have a horizontal asymptote. So take this equation, as x goes to infinity, x minus 3 goes to infinity, that means y goes to 0. So the horizontal asymptote is y equals 0. As x gets larger and larger and larger, this fraction gets smaller and smaller and smaller, approaching 0. So we have a horizontal asymptote right there, and that's y equals 0. Okay, let's see. Because we removed, let's look at the whole. The whole is that we canceled out x plus 1. So that means we have a whole at the x value coordinate is going to be x is negative 1. So we take the equation y equals 1 over x minus 3, and we plug in negative 1. So negative 1 minus 3 is 1 over negative 4, which just make it 1/4. So the whole is at negative 1, negative 1/4. So the whole is that, so negative 1, x is negative 1 here, and this is a negative 1/4, so let's say the whole is right there. But we know with asymptotes, horizontal and vertical asymptote, you can't cut through a vertical asymptote. So either the graph is here like this, or it's here like this, or it's here, going up along here down to this horizontal asymptote, or here. So we got to find out where it's going to be. So let's go with let's see, we know it's, we know it's a hole here, so it has to be over on this side. So let's do a table of values. And we got vertical asymptote at 3, so let's look at a 4. Plug 4 into this equation. So if you plug 4 into this equation, you're going to get, this is the equation, 1 over 4 minus 3. So that means you're going to get 1 over 1. So you're going to get, when x is 4, y is 1. When x is 4, y is 1. There it is. So we know it's here. Because it's in here, that means it goes, it can either go like this, or it got to go like this. But remember, as x goes to infinity here, y is approaching 0. So it has to go this way. Like this. And because that's the hole, that means it has to come over here. So let's plug in 2. So 2 is on the other side of this vertical asymptote here. X is 2. So plug a 2 in here, we get 1 over 2 minus 3. So it's 1 over negative 1 is negative 1. So we get 2 is a negative 1, which is here. So that's a point on the graph. And again, it goes through here and here, so it has to come, it's going down like this. And coming through here. And remember, the horizontal asymptote, so it goes through this point, and it's, as x goes to negative infinity, y is approaching 0. As x goes to positive infinity, y is approaching 0. So that's, notice there's a hole right there at negative 1 quarters. So it's the same graphs that we had before in previous videos, but I just wanted to illustrate when there's a common factor, you take it out. But when you take out that common factor in this rational function, then you have a hole in it. So that brings us to the end of this video on the common factor that we remove, creating a hole in the graph. And again, if you like the video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my video, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.